Let's do one example for the oblique collision. In this problem, 212, chapter 3, we have two particles which are moving in these given directions before the impact, and at this moment they are colliding. After the impact, they're gonna move away from each other. The mass of them is the same, and coefficient of restitution is 0.75. And we want to find the velocities after impact, and also we need to figure out how much energy we are losing here during this impact. So again, stop this video, think about this problem at least for 10 minutes, then see the rest of the video. Okay, during this collision, the normal direction is going to be x, and the tangential direction is going to be y. It's just a name. You can replace this with t and also this one with n if you like. And based on the previous video, as I explained it, the velocity of the particles is not going to change in the tangential direction. So after impact, the velocity of them in the y direction is going to remain the same as before impact. So the velocity of A after impact in the y direction is going to be equal to velocity of A before impact in the y direction. Velocity of this particle before impact is 10 with the angle of 30. So the y component of it is going to be 10 times sine of 30, which is going to be equal to 5 meters per second. Same thing goes for B. Velocity of B after impact in the tangential direction or y direction here is going to be equal to the velocity of it in the y direction before impact, which is 6. So far we got two of the unknowns. We have two other equations, right? Conservation of linear momentum for both particles together in the normal direction, which was this equation. Let's say the mass of both of them is m. So m times velocity of A after impact in the x direction or normal direction plus mass of B times velocity of it after impact in the normal direction or x direction is going to be equal to the velocity of each of them times the mass in the normal direction before impact. So it's going to be 10 times cosine of 30 for this one. And the velocity of B in the x direction before impact is 0. So we are going to have only 0 here. M is going to cancel out from this equation. So we got one equation for VA prime and VB prime in the x direction. The last equation comes from coefficient of restitution. E is equal to velocity of the second mass, or A or B, it's up to you, in the normal direction or x direction minus velocity of the other mass in the normal direction after impact divided by VA in the x direction minus VB in the x direction before impact. So VB prime in the x direction minus VA prime in the x direction is going to be equal to E times this. E is 0.75. Velocity of A before impact in the x direction is going to be 10 times cosine of 30 minus velocity of B in the x direction before impact, which is 0. So we got two equations for these two unknowns. So we have a system of linear equations which we can easily solve them. So if you do the math, VA prime in the x direction is going to be equal to 1.083 meter per second, and VB prime in the x direction, or velocity of B in the x direction after impact, is going to be 7.58 meter per second. Both of them turn to be positive. It means after impact, velocity of both of them in the x direction is going to be positive, right? B is going to move in that direction and A is going to move in that direction. And you can easily calculate the direction of them after impact, because for example for B, you know velocity of B after impact in the x direction and velocity of B in the y direction after impact. Combination of these two is going to be the velocity of B after impact. So velocity of B after impact, the magnitude of it is going to be VB prime in the x direction is squared plus VB prime in the y direction is squared, which is going to be equal to 9.67 meter per second. And the direction of it is going to be tangent inverse of this velocity divided by this one, right? Obviously, which I'm going to let you do that part yourself. The same thing for A. VA prime is going to be equal to a square root of VA prime A in the x direction is squared plus V prime A in the y direction is squared, which is going to be 5.12 meter per second. To calculate how much energy we are losing here, we need to calculate the kinetic energy before impact, which I'm going to show it with 1, and after impact, which I'm going to show it with 2. So the kinetic energy is going to be equal to 1/2 of mass, which is the same for both of them, times velocity of A before impact squared plus velocity of B before impact squared, which we know the velocities. And if you plug in the velocities, which are 10 and 6, it's going to be 68 times mass. Same thing for after impact. It's going to be V A prime squared plus V P prime squared times 1/2 times m, which is going to be equal to 59.8 times the mass. To calculate how much energy we are losing, N is equal to change in the energy divided by the initial energy, which we have only kinetic energy here, so you can replace this E with T as well. So change in the energy, you need to subtract this from this and divide it to the initial energy, which is 68 times N. And also we usually multiply to 100 to find it in percent. And if you do the math, it's going to be 12.06%.